Welcome to the Learning Pines YouTube. We hope this video helps.
You begin by gathering the physical numbers you need: light speed in vacuum C and measured speed V in the medium. Once done, plug into N equals C/V to get the refractive index. This gives the fundamental ratio that explains bending. Make sure to also measure incident angle θ1 and transmitted angle θ2 when working at an interface, because you can cross-check with N equals sin θ2/sin θ1. Start calculating now. No extra setup is necessary. Use precise units and note uncertainties. You now apply Snell's law to connect indices across an interface. Start by substituting known N1 and θ1, then solve for N2 or θ2 depending on your unknown. Once done, rearrange algebraically. For example, N2 equals N1 sin θ1/sin θ2, or compute θ2 equals arcsin, N1 sin θ1/N2 when angles are unknown. Make sure to use consistent trig mode in your calculator. If you measure angles in degrees, set the calculator accordingly. This step converts raw measurements into predictive refractive behavior. You complete the workflow by cross-checking values. Compute N from speed C/V and separately from Snell's law, then compare results. Once done, interpret discrepancies. If N1 is larger than N2 and sin θ1 exceeds N2/N1, expect total internal reflection instead of transmission. Make sure to inspect measurement errors, unit mismatches, or misaligned optics when values disagree. If problems persist, recalibrate angle references and remeasure V. Small errors in angle or speed produce large index differences.
Thanks for watching. Consider subscribing if we helped you.